Hello everyone, welcome back once again to Nated Engineering. We are still on heat engineering science and today we will be looking at expansion. I'm sure by now we all know how materials react to temperature increase. Like let's say we are having a material of length L. Initially, let's say the temperature is let's say 20 degrees Celsius, and for some reason there is a change in temperature from that 20 to 60 degrees Celsius. This we are going to say is T1, and then we are going to have our T2, which will be 60 degrees Celsius. So by now I think we know how materials react to temperature difference in terms of the length or their size. The universal response to this change in temperature will be that we are going to experience a change in length. And because the temperature is increasing, meaning our length will also be increasing. We know the way materials react to temperature change is that if we're having a change in temperature and it's let's say it's an increase in temperature, the material will increase in size, and if we are having a decrease in temperature, that material will decrease in size. So here we're having an increase in temperature from 20 degrees Celsius to 60 degrees Celsius, and then we are having what? The change in length. The length of the material now will be from here, let me write it like this, is to here, and then we are going to say this is the final length, and then we are going to say this portion is the change in length, is the length that was added due to the temperature difference. And we know if we want to calculate for the final length, we are going to need what? Let's say this is the original. The original length plus the what? The change in length, which is delta L. We have a formula to calculate delta L. The change in length is given by the original length times the coefficient of linear expansion times the change in temperature difference, which will be T2 minus T1, change in temperature. So this, I think we know this. Whenever we are having a heat increase, the material that is subjected to that temperature increase, it will increase in length. And the way we calculate for the final the final length, is we are going to say the original length plus the change in length. And the formula to calculate our change in length is original length times the coefficient of linear expansion times the temperature difference. You will be given the linear expansion, coefficient of linear expansion. So let's say now we are having a material, but the heat energy or the temperature is not increasing but decreasing. What is the universal response to that? Is that this will be our original length, which is L, original length. The material will decrease in temperature. Why? Because we are experiencing a temperature decrease. Let's say we got from 60 to 20. That's our T2 to 20 degrees Celsius. Now the temperature is going to decrease. Our final length will be this one. that will be our final length. Remember, the material is was initially this size, and as the temperature is decreasing, it will shrink from this point back to this point. So that is why our final length is from this point to this point, meaning this is what is our change in length. And to calculate for the change in length, we use the same formula. The only difference here will be that our final length will now be equals to the original length minus the change in length. Because we can see that the change in now on this scenario number 2, our final length is smaller than our original length compared to what we had on the first one, where our final length was longer than our original length. Here it was because, let's say this is number 1, this is number 2. Here it was because the material is experiencing an increase in temperature, and as a result it is increasing in length. And number 2, we are experiencing a decrease in temperature, and as a result we are having what? A decrease in length. And this is when we are only focusing on the linear expansion, meaning that we are only focusing on the length of the object. Because the reality of the matter is that if we are having something like this, and then we increase the temperature, it's not only this side that is going to increase in length, also this side is going to increase in length. But when we are dealing with linear expansion, we ignore the increase in length that this side will experience, because we are only interested in the linear part of it. It's, for an example, when we are dealing with a rail line, we are dealing with a rail line. Let's erase this. When we are dealing with a rail line, if you have ever seen a rail line, you will notice that when a rail is installed, they leave gaps in between, because they know that when it's hot, these two will increase in length, and they will have to be given clearance, or they will have to be given space to be able to increase in length freely. In a case like this, we do not really need to focus a lot on this length, because we are more focused on the length of the rail, not the breadth of it. But that doesn't necessarily mean the breadth is not increasing in length. It simply means we are neglecting it because we know it's not going to do much damage. We have something else. This one is called a linear expansion. We have something else which we call what? An area expansion. We know area, it's equals to length times breadth. I think by now you already guessed. When we are dealing with area expansion, we are taking into consideration the change in length experienced by the breadth and the change in length experienced by the length. So we will be dealing with something like this. This is our length. And this is our breadth. The reality is that if we increase the temperature, this block will experience a change in length like this. This will be our original length. and this will be our original breadth. From here to here will be our final length, and this will be our final breadth. But we're not going to do them separately one by one because we are dealing with an area. So the formula that we are going to use when we are dealing with area expansion is that area, change in area, it's equals to the original area, which is equals to length times breadth, times beta times the temperature, change in temperature, where our beta is equals to 2 times the coefficient of linear expansion. You might be given a question where they don't give you the value of beta. This is the coefficient of area expansion. In a case where you are not given the coefficient of area expansion, but you are given the coefficient of linear expansion, you must know that the coefficient of area expansion is 2 times the coefficient of linear expansion. So take that value, times it by 2, and continue with life as we know it. So in this case, we are going to say the final area is equals to the original area minus plus the change in area when we are having what? Temperature increase. So when we are having temperature decreasing, meaning it will come, let me change color. It will come here. So in that case, we are going to have our final area being equals to the original area minus the change in area. One thing that you have to know is that beta is equals to what? The area expansion, the coefficient of area expansion, and it is 2 times the coefficient of linear expansion. In a case where you are given the linear expansion, don't say I can't perform calculations because I don't have the area expansion. You know that the linear expansion is the area expansion is 2 times the value of the linear expansion. And this is everything that you need for us to be able to start attempting questions that deals with expansion under heat engineering science M3. It's not a lot. You just need to know how to calculate the final area or the final length if you are dealing with linear expansion, how to get the change in area or how to get the change in length if we are dealing with linear expansion. And you must know that area is equals to length times breadth. So if you're given a question, you're given the length, you're given the breadth, before you perform calculations, calculate for your area. Don't come and put the length here alone or the breadth alone. Calculate for the area, and then by the time you get here, this is the original area. And I think we have covered everything. I will see you on the next lesson.